Hi everyone. This is section 1-2 in Algebra 1A, and today we're looking at the concept of functions. Now, functions are kind of a big deal in the world of algebra, and I'm not sure if you've seen them before or not, so we'll start with this definition. A function is a relationship between two sets where each item in the first set is paired with exactly one item in the second set. So really what functions are all about is pairing things up. It's a correspondence. It's a x with a y, that kind of thing. That's what a function is it's a relationship between two things, okay, where two things are being paired up together. The important part, the part that makes something a function, is this piece right here, this exactly one terminology, and you'll see this in action in just a minute. But what we're on the lookout for is when we take this first group of items, and in math, a lot of the times our items are numbers, and we're pairing them up with things in the second set, everything in this first set only gets to have one partner over in the second set. Now, what gets a little bit confusing about that is you are allowed to have more than one thing from the first set share an item in the second set. And you'll see that when we get down here to the examples. So that can get a little bit confusing about functions, and that's really where our focus is today, is understanding that relationship. So we're talking about this first set and the second set, and then we have some other words that we can apply to those things, the first set and the second set. The items in the first set are what we refer to as the independent variable, and we're always taking the independent variable and pairing them up with the dependent variable in the second set. Okay, so independent variable is the first set, dependent variable is the second set, and then we get to domain and range. Domain is talking about all of the possible things that could show up in that first set, the independent variable. Range is talking about all of the possible things that could show up in that second set. So we're going to be using these words quite a bit. Sometimes with domain and range, you can literally list the items in the set. So sometimes you can say, oh, my domain is this number, and this number. Sometimes it's more general, where you're saying it could be any whole number or any integer or any positive number, in which case you can't possibly list them all. So you can have a finite domain or an infinite domain. And I just want to jot those words down here, that this can be finite, which means you list them, okay? Or they can be infinite, in which case you're going to name a particular set of numbers, and we're going to cover those sets of numbers later on in the lesson, okay? Okay, so let's go back to this concept of a function real quick, and we're gonna draw out some ways that functions can show up. There's lots of different ways that you can look at functions, and I really want to focus on this idea of the exactly one pairing. So one of the ways that we see functions a lot, and this is the way I think is easiest to see that unique piece, is we can put our sets of numbers in these bubbles. So maybe this is my first set of numbers, 1, 2, and 3. And I'm going to pair them up with the numbers. I'm not super creative here, so I'm going to go 4, 5, and 6. Okay. And I can pair them up any way I want. So 1 gets matched up with 5, 2 gets matched up with 4, 3 gets matched up with 6. That is a function relationship, because each item over here in this first set has exactly one partner over on the other side. Okay. By the way, my domain here would be 1, 2, and 3. My range would be 4, 5, and 6. This is a finite one, meaning I can literally list the items in the domain. Okay. It is okay if I throw another number in this first set. Maybe I'm going to throw the number 9 in this first set. I'm going to add it to the domain. And I'm going to let 9 pair up with 5. Now, notice that means now 5 is getting paired up with twice, but 5 is in the second set of numbers. We actually don't care about that. We're okay with that. As long as each number over here is only getting paired up once, this is still a function. This is allowed to happen, okay? What's not allowed to happen is if I were to do something like 1, 2, and 3 matched up with 4, 5, and 6. If I were to take 1 and let it match up with 4 and 5. That's where we have an issue. We can't have anything in the first set of numbers get matched up more than once over here in the second set, no matter what's happening over here. So if I just do this, again, we're okay with this 5, but we're not okay with this 1. This is the issue, okay? Kind of a double standard mathematically. We're okay with this happening. We're not okay with this happening for it to be a function. Okay, so this is not a function. I'll be honest though, you aren't going to see these diagrams very often other than in this section where we're trying to wrap our heads around this exactly one piece of this definition. A lot of the times in math, we don't write things like this. We write them as ordered pairs. So I might list a function like 1 comma 5, 4 comma 7, whoops, and 3 comma 9. And that is a function. Here we're matching up x's with y's. So all of my x's would represent my domain and all of my y's would represent my range. And you'll notice that every x value only gets matched up once. So 1 is only matched up with 5. 4 is only matched up with 7. Okay? Let's take that same 1 and turn it into something that's not a function. So I'm going to start with those same pairs. And I want you to think while I'm writing here, what could I add to this? What other coordinate could I possibly add that would turn this thing to something that's not a function? Well, remember what we would want to see happen is one of our x values would have to have more than one partner. So if I suddenly added 4 comma 10 to my list, suddenly that's an issue, okay? Because 4 now has 2 partners. 4 is matched up with 7 and 4 is matched up with 10. And that's the thing that would make this not a function. So if I hand you something like this and I say, tell me if this is a function, what you're looking for is whether or not the x's repeat, okay? The x's are what's important because the x always represents your independent variable. And actually, I'm going to throw that in up here. The independent variable, when we're talking algebra, is always your x values. The dependent variable is always your y values. Okay, there's a lot of different ways we could look at functions. We can look at them as ordered pairs. Sometimes they're going to show up in tables or graphs, charts, things like that. I do want to look at the idea of an equation as a function because that's where we get into this infinite domain and range. So if I give you something like this, y equals 3x plus 1. Remember how this thing is supposed to work. This is allowing you to plug numbers in for x, okay, anything you want, and then do the calculation and then get a number out for y. You've got like an input and an output, right? And so when we're asking ourselves whether or not this is a function, what we want to ask ourselves is if I put a number in here for x, doesn't matter what number, will I only get one number out for y? Or is it possible to get more than one of the same, or more than one answer with the same input? So if I drop a 5 in here, I'm going to get some number out for y. And then I can say 5 gets paired up with, let's see, it would be 16 if I put 5 in right here. Okay, so 5 gets paired up with 16. Is there any way that I could put a 5 in there where I would get an answer other than 16? And the answer here is no, okay? Now I could drop numbers in here all day long, and that's what my infinite domain is what are all of the numbers that I could throw in here for x? We're going to talk about how to answer that question later. But every number I put in spits out a unique answer for y, and that's what makes this thing a function, okay? Is that it gives a unique answer for every value of x you plug in. That's a little bit harder conceptually. You know, you can't see it like you can see it here. But I will tell you that in algebra, this is almost always true. It's almost always true that if you put in a single number for x, you're only getting one single number back out for y, okay? There's a couple of real specific examples where that doesn't work, and I'm going to give you one of them right now. So, for example, if I give you the square root of x, x is still my input, so I'm going to drop a 25 in there and think about what I'm going to get out as an answer. Okay, so I'm dropping 25 in for x, then I take the square root of it, and we have to ask ourselves, what is the square root of 25? Well, Square root of 25 could be 5, but, and this is going to be a big concept later on this year, it could also be negative 5, right? Square root of 25 could be 5 or negative 5. And so what that means is I dropped in one number and I got two possible answers out. So this would not be a function because I have one input with multiple outputs, okay? This is probably the biggest one you're going to have to know as far as being not a function. Almost every other equation you're going to run into will be a function, okay? Okay, some wording for us to understand, and you'll see the importance of this wording in just a minute. I'm not sure if I left this in your notes or not, but you're going to want to write this down. This is kind of the phrasing that we use when we talk about functions. We say the dependent variable, which for us is a lot of the times y, although we can use other letters, is a function of the independent variable, which is x. The reason you have to know how this sentence is structured is when I say a sentence like this, I want you to be able to look at the end of the sentence and say, okay, this thing down here at the end is supposed to be my independent variable because this is where we're looking for repeats, okay? So if you need to, pause the video right now and get that sentence written down because you're going to want to know it. You're going to want to know it right in this first example. Okay, so we're looking at a table of data here. And this is years versus the percentage of people that graduated high school but did not attain any other higher education beyond high school. So the number of people with just a high school diploma, okay? And look at the phrasing here. Is P a function of Y? There's that sentence, right? P a function of Y. I can look down here after the of and know that this is implying that Y is supposed to be my independent variable. And that P would be my dependent variable in this situation. And that helps us know which one do we care about the repeats in. Remember up above, it's the independent variable we don't want to have repeating. So if I look across my Y values here, my years, 2009, 2010, what I'm looking for is there any year that gets matched up with more than one percentage? So does 2009 have one percentage listed here and another percentage listed down here? It doesn't. Every year has its own unique value, right? So I would say yes. And I know it doesn't technically ask me why, but these are your notes and you're probably going to want to write this down. I would say because the independent variable, or we could just say the y, does not repeat. Okay. This question also asks for domain and range because it is a function. So here's the tricky part about a question like this one, and this is why I clarified up there the difference between a finite and an infinite domain and range. When I ask you for the domain, I'm asking you what are the possible values of the independent variable. So a lot of the times when I ask this, people will tell me, oh, the domain is y. I see why you're saying that. You're right. The domain is this variable right here. But I'm not asking you for the variable. I'm asking you what are the possible values of the variable. And especially when it's given to you in a table and you can list them out, you should list them out. So for my domain, I'm going to literally list the values that make sense for the year. I hope I left myself enough room here. I did not. Okay, so when I ask for domain, you're literally listing the values that the y value could be. Same thing for the range. So the range would be the values of the dependent variable. So I'm listing these percentages. Now, I'm going to tell you how to be mathematically proper here. I will tell you this is not something I nitpick about a whole lot. But when you list numbers in a set, we really should put them in numerical order. And you don't have to list repeats. So I'm going to start with the 50. And I'm going to say 50%. Jury's kind of out on whether or not we need to include the percentage sign here. I'm not sure, but not something I would mark down for either way. And notice I'm only listing the 53 once, even though it does repeat. We're okay with it repeating because it's in the it's in the range. Okay. This next question kind of irritates me, if I'm being honest. And here's why. So let's talk about how this question is different. This question now says, is y a function of p? Notice that's backwards from what this was. And what that does to us, if y is a function of p, now it's telling me treat p like the independent variable, okay? So it wants you to switch this around and make it so that this is independent and this is dependent. And here's why I don't like them doing this to you. We never make tables this way. When we display data in tables, we always put the independent variable first. So even if I didn't give you this wording here, when I hand you a table, you really should be able to look at it and assume that the first one is your independent variable. They are only doing this to you to make sure you understand the structure of that sentence. Okay, and this is probably the only place that this is ever going to happen where I switch them around on you. But we can answer that question. If we switch this and we make this independent, is this thing still a function? I would say no. And think about why. No, because the 53% has two different partners. Okay, now this is independent, so now this is what I'm worried about repeating, right? And so I can say 53% is paired up with two different years. Okay, so that was a no, and then I'm explaining why not. 53% gets paired up twice. I didn't care about that 53% repeating when it was the dependent variable, but now that they made it independent, now I care. Okay, so that's it for the first part of this lesson. If you wanted to, you could, pause here if you just want to take a break from the video, get started on your homework assignment, and then come back and watch the rest of the video to finish up your assignment with anything that you're still missing. But in the next part, we're going to talk about the different types of number sets to be able to name infinite domains and ranges, and do a couple more examples of domain and range questions. Okay? All right, so stay tuned for part 2.